This is the fourth and final part of this story of construction of the Hume Dam. In this part we will deal with aspects of the project not covered in the first three parts and conclude with some reflections on the significance of Hume Dam. This is a group of quarry workers dressed for work. They wore no safety equipment. Hard hats, fluoro vests, work boots and the like were missing. Many of these men, perhaps most, were returned soldiers. They were used to hard work and difficult conditions. Estimates of workforce numbers vary widely. In the mid-1920s, at the peak of construction, there were more than 1,200 workers, all male. We have a set of numbers for 1927. The Victorian Embankment construction site had 355 men working on that part of the project. New South Wales had 650 working on the spillway, and there were a further 89 men employed in construction of the Basin Bridge. When the economic depression of the 1920s and early 1930s bit hard, these numbers dropped significantly and the whole project slowed down. The men worked a 48-hour week, 8 hours a day, 6 days a week. After industrial action, this was later reduced to 44 hours, giving the men Saturday afternoon off work. Manual labour was harsh. With such a large workforce and dangerous working conditions, accidents were always waiting to happen. There were many serious accidents, many of which left workers with permanent disabilities. But surprisingly, there were few deaths. The most serious accident occurred on October 25, 1921. Jacob Gehrig Sr., aged 55, George Pearce, 62, and William Wakeford, 17, were killed while attempting to retrieve unexploded blasting powder. On April 17, 1923, Henry Stanley Mead, 19, was crushed between rail trucks on the New South Wales side. In an accident not related to construction, on November 24, 1925, John McNamara, 43, fell from the elevated back veranda of his house, striking a wood horse. On March 30, 1928, John Glenn was a driller working on the face of the stone quarry when his drill jammed, and in endeavouring to free it, he missed his footing, falling 20 metres to his death. On April 16, 1935, Jack Newman, 37, a carpenter, was killed when he fell 12 metres onto concrete from wooden decking. In a bizarre twist, a workmate, Jack Meads, aged 30, was hit by a car and killed in Mate Street, Albury, while riding his bicycle home after attending Newman's funeral. Housing was provided for workers at Weir village for New South Wales workers, and at Junction, sometimes referred to as Ebden, for the Victorian workers. There were barracks for single men and houses for workers with families. This photo shows housing in Junction. This is Junction again, with workshops in the foreground and housing behind. The workers and their families were provided with free firewood, water and electricity for lighting, but there were no phones, no electric appliances, no hot water and no radio. This is the main street of Junction. It is the only photo in this series that has a woman in camera. The lady in the middle of the street looks like she may be returning home with her shopping. Mitter Junction again. On the left-hand side, the sign above the first car advertises various newspapers, so it's a news agency. Further down the road, a car fills up at a petrol station selling plume fuel. On the right-hand side, the sign above the car is for the Ebden Cafe. Advertising on their signage reads, "Meals at all hours." Both villages had recreation halls and dances, and picture shows were enjoyed. The baker, the milkman, and the greengrocer called regularly, as did the iceman. Each village had several privately run businesses, and alcohol sales were banned. This photo is looking north at Hume village from the Flying Fox Tower. Hawksview is the hill in the background. Both the New South Wales and Victorian villages had a church. In Hume village there was a post office. A police presence was established. There was a casualty ward. They had a doctor who had a phone and a motor vehicle, and they had a 9-hole golf course. There was a primary school in both villages, the New South Wales school having 66 pupils in 1921. The sign on the school in this photograph reads Mitter Junction Reservoir School, number 4080. Secondary age children were bused into town. Sport attracted many, with competition in tennis, golf, football and cricket. Both Ebden Weir and Hume Weir cricket teams competed in A grade of the Albury and Border Cricket Association competition between 1922 and 1929. The photo is of the Hume Weir football team, premiers in the Albury and Border Football Association in 1922, easily defeating Albury. Hume Weir players mentioned in newspaper reports included B and C Whiteley, Baker, Webster, Grenell, Corbett, McPherson, Stewart, McAlpin, Rutter, Parkhill, Haywood and Norris. Later, Hume Weir football team competed in the Avonson Murray League and Mitter Junction in the Chiltern and District League. In 1929, both football clubs merged to form Weir United, and they were premiers of the Avonson Murray League in 1930 and again in 1931. Now we will have a look at some of the equipment used on the job. Brought to Hume after being used in the construction of Junction Dam, the Flying Fox Tower was built of Oregon timber. In this photo are the men who were brought down from Junction in 1922 to reassemble the structure at the Hume Dam site. The Flying Fox is now in place on the New South Wales side of the site. It was about 25 metres tall, and the tower could move about 115 metres east to west on 4 rail tracks, so that it could deliver loads to most of the spillway worksite. It could lift and carry 10-tonne loads across the 400 metres to the southern side of the spillway. A man sitting in a small enclosure at the top communicated by telephone with supervisors below to operate the Flying Fox. It was held down by about 300 tonnes of concrete blocks at the base, giving it a low centre of gravity. Behind the Flying Fox is the coal-fired power station building, generating electricity for the New South Wales worksite. Beside the generator building is the power station's condensing tower. This is a photo from the top of the Flying Fox Tower with the 4 railway lines below, across which it could move 115 metres back and forth, east to west. We also get a good look at the condensing tower and the power station building and a quickly filling lake in the background. The Bucyrus steam shovel could shift 3 cubic metre loads and ran on caterpillar tracks. Here it is seen during excavation on the New South Wales side of the river during the early stages of construction. A variety of cranes, diggers, scoops and navvies, mostly wood-fired, were deployed. Both quarries made considerable use of rail on which to run their cranes, loaders, etc. Steam locomotives were used extensively. Here is a locomotive belonging to the New South Wales Public Works Department. Both states made extensive use of a 900mm narrow gauge rail, taking clay and stone to their respective work sites. Frequently the lines had to be relocated as the work progressed. New South Wales had a line inside their cofferdam to remove rubble while excavating for the spillway foundations. Victoria had 10 steam locomotives working on the embankment. New South Wales had 4. Their busiest route was to and from the quarry near Bathanga Bridge. A fleet of 10 solid rubber-tired Thornycroft motor lorries capable of travelling at 10 miles per hour or 16 kilometres per hour shunted vast amounts of stores, equipment and cement to the dam site from a rail siding located at North Street in Albury. This is the concrete mixing plant and a load of cement bags being delivered. The rail line behind brings crushed stone from the quarry. In spite of it looking in the photo like a primitive operation, the output was impressive. There were 2 huge concrete mixers, sometimes exceeding 3,000 bags of cement consumed in a day. This translated to over 700 cubic metres poured on site in an 8-hour working day. 25,000 bags of cement were kept on reserve at the site, with that many again at the North Street siding in Albury. This is the New South Wales quarry. 2 quarries were established, the one in Victoria providing earth fill and clay for the embankment. In New South Wales, the stone quarry on the eastern side of Hawkesview Hill supplied good quality granite. Rocks blasted out of the quarry face were used as plumbs in the spillway wall. These rocks make up about 17% of the spillway wall. Some of the rocks were taken to the crusher at the quarry. That provided crushed rock for use in concrete. 2 steam navvies are at work, loading rock onto rail trucks. The rail track was all downhill from the quarry, so rail trucks used gravity to haul crushed rock or whole rocks to the worksite. The locomotives then pulled the empty trucks back to the quarry. The quarry overlooking the lake and Bathanga Bridge remains to this day as a gaping hole overlooking the lake. Here we have an aerial shot of the site looking south across Hume Weir village, over the spillway to the embankment beyond. We can see the Flying Fox towers still in place, the power station building, and at left the rail line heading back to the quarry. Much of 1936 was used to clear up the site, including the villages. 3 months before Governor-General Lord Gowrie symbolically opened a valve on November 23, 1936, signifying the dam's completion, a massive auction sale took place. Over 3,000 lots were offered for sale over 6 days. Items included locomotives, trucks, rails, electric motors, generators, stone crushers, steamrollers, lorries, stores, buildings, houses, boilers, and even an automatic telephone exchange. Environmental problems started well before the dam was complete. One problem not so well known was caused by the rotting vegetation as the dam filled. It resulted in excessive growth within the lake of blue-green algae, or more correctly, cyanobacteria, as the dam filled. For more than a decade downstream, users complained of the putrid taste and smell of their water. Part of this 1929 article reads, "The erection of the Hume Dam had caused the flooding of country on which was a vast accumulation of debris, grass, manures, and the bodies of dead animals. The water was practically stagnant, and the hotter the weather, the worse the water would become. Present conditions were a menace to the health of the town." The solution? The authority decided to treat the water with large doses of copper sulfate. The result? The copper sulfate killed blue-green algae, but the large doses also decimated native fish populations, not only in Lake Hume, but all the way down the Murray River as far as Barmah. This issue remained a serious problem for at least 10 years. Another problem was cement used at the dam construction site. For years, the concrete conveyor belts and the form work or boxing was pressure cleaned each day, the cement being hosed into the river. River management was an issue that created headaches for Albury town councillors in 1939. Following a severe drought, the Murray River Commission decided that to refill an almost empty Hume Dam, there would be no releases from the dam. The result? There was just a muddy pool at the waterworks, from which Albury's water supply was drawn. Fortunately, this problem was resolved and not repeated. We will now consider a few of the environmental impacts since completion of the dam. Providing an assured water supply has supported agriculture, which in turn results in more use of agricultural chemicals. While this contributes to elevate agricultural production, some of these chemicals are toxic and others result in accelerated blue-green algal growth. Control of river flow is a factor increasing salinity in the Murray-Darling Basin. In the river's natural flow, salt gets washed to the sea. But less water now flows out of the Murray mouth, and this means that more salt is left on land. The dam has also thrown up some ecological challenges that we are continuing to deal with. Arguably, the most significant of the problems caused by containing the water of the Murray River and its tributaries has been the effects of the inversion or reversal of the natural seasonal patterns of river flow. Before the Hume Dam, the Murray was normally at its peak of flow during winter and into spring. Low water levels were experienced during summer and into autumn. This natural flow is now reversed, with water stored in winter and released in summer for irrigation. So now we have low winter river levels and high summer levels. The altered river flow and the colder water temperature has had serious impacts on native fish and crustaceans, upsetting breeding cycles. But it has favoured introduced species such as trout and carp. While flood mitigation is important, often our floodplains and wetlands are now starved of water. This has a significant impact on migratory bird species and on the health of our river redgums. Magnifying the problem, the dams and locks on the river impact on the mobility of fish and other aquatic animals. For many species, migration is a crucial factor in their breeding cycles. so threatening survival of the species. We will now consider some of the engineering challenges. To maintain the structural integrity of the dam, remedial work has been required almost since the first year it opened. Major work has included some of the following. In the decade of the 1950s, work began on raising the water level of the dam by 8 metres, with the installation of gates across the spillway. This resulted in elevated uplift pressure on the spillway wall. The problem was addressed by drilling scores of holes through the wall and down to bedrock, and then inserting tensioning cables. These cables are retensioned every 5 to 10 years. Remedial work has been ongoing along the Victorian Embankment, with substantial strengthening required. In 2013, a concrete buttress was constructed to strengthen the southern downstream training wall. The photo on screen shows work in progress on the training wall and the strengthened embankment behind. And extensive remedial action has been required at the southern end of the spillway. This has been as a result of water seepage and movement at the junction of the tail tower and the embankment. But notwithstanding these problems, we can't underestimate the dam's significance and the positive impacts of the dam's construction. The dam was and is one of the great engineering works in Australia. It is well sited, huge and built by a combination of manpower, horsepower and steam power. Having cooperation between the federal and 3 state governments must be recognised as a significant political achievement. Recall that the Royal Commission of 1902 highlighted 3 priorities for the River Murray Commission: navigation, irrigation and a stable water supply. Discounting navigation of the river, as it was already becoming irrelevant in 1902, 2 of these aims have been achieved. The Murray-Darling Basin supports about 70% of Australia's irrigated crops and pastures, and by 2021, agriculture was generating an estimated $24 billion each year. In 2021, the Murray-Darling Basin is home to almost 3 million Australians, and while droughts will always be an issue, they are less frequent. And likewise, flooding, while still a significant problem, it is less frequent and generally its effects are less severe. Nor can the importance to Albury's local community be underestimated. The Hume Dam put Albury on the map in the early 20th century. To quote Albury historian Dr. Bruce Penney, Albury seized on images of the dam to brand itself as progressive. The dam has helped attract people to our area, boosting tourism and helping shape our local community. At the local level, we recognise the social significance of the Hume Dam for its contribution to the community's identity and as a long-term source of employment in the valley. And what Albury and District Local has not brought visitors to the dam site to admire the incredible engineering achievement, or has not been swimming in the lake, or fished, or skied, or sailed, or all of the above. For all of this, the benefits of the construction of Hume Dam, both social and economic, that communities, users, irrigators and the like have enjoyed along the 2,200 kilometres of the river can only be described as immense. This 4-part series on construction of the Hume Dam is now complete. I have been able to complete this project accessing a wide range of valuable resources, including those listed on the screen.